Welcome, polar bears and polar cubs. We got quantum numbers. It's chapter 4, section 2. So, what do quantum numbers kind of represent? What do they tell us? Well, they're talking about orbitals. Okay, so when we're talking about orbitals and we are talking about quantum numbers, an orbital is three-dimensional region. So, it's actually, like an orb or a sphere that we're talking about. Each electron gets 4 of these quantum numbers. So each one tells us something. So 3 of them combined will tell us the location. So if you think about it, I say it's like a hotel. Okay. 3 things that you can be told on a hotel. You can tell floor, like the actual room, and then what part of the room. So like the bathroom or the bedroom, or some places have like a living room, depending on how big it is. You can almost think of it as an apartment building if you really want to. Part of the room. Okay, so those are the 3 locations. And then the 4th one tells you about motion. So these 4 quantum numbers. The first 3 are the ones that tell us about location. The 4th is the one that tells us about spin. So principal quantum number tells us what floor it is, pretty much. Angular momentum tells us what room it is of the floor, like or what apartment it is. And then the magnetic quantum number tells us what room within that apartment it is. So an apartment building probably works better than a hotel. And then the spin quantum number tells us within that room, how is it spinning? What activity is it up to? So the principal quantum number, it's represented by N. It tells us the energy level of the electron. So it tells us what floor. They're always positive integers. And the higher the N value, so the higher the number, like 7, the further away we are from the nucleus. So these are your, like, the higher you are, you would be, again, higher up in your apartment building, and you can't really hear or see what's going on below you. And then you have higher energy if you're higher up, because you have more potential energy of falling down. What N can tell us, if it's squared, it can actually tell us the number of orbitals. So for the 4th energy level, if you take 4 squared, that is 16, telling us that there are 16 orbitals within the 4th energy level. It can also, if it is multiplied by 2 after squaring, it can tell us the total number of electrons. So for 3, if you square that, it gets you 9, and then multiply it by 2, giving you 18. So what that's telling us is that on the 18th energy level, or I'm sorry, on the 3rd energy level, you can have 18 electrons. The angular momentum quantum number would tell us it's a lowercase cursive L. Okay, but if you were ever asked to type it in, it would just be a normal L. It tells us the shape of the orbital. So by telling us the shape, it's telling us what apartment. Okay, it's telling us what apartment. So we have S orbitals, which are spheres. We have P orbitals, which are dumbbells. I know you're looking at me or listening to this and going, hey, you know what? That doesn't look like a dumbbell. It looks like almost like an infinity sign. Well, old school dumbbells used to look like this. Okay, so that's why it was called a dumbbell shape. And then D and F have a far more complex shape than we ever really get into. So sublevels is the kind of associated term with the lowercase l or the angular momentum. It tells us the sublevels or sub shells. So levels can be shells, if you want to think about it that way. And there are 4 sublevels within each shell, or possible 4 sublevels within each shell. For each energy level, the possible number of orbitals is n. So pretty much what it's telling you is as you go up energy levels, you get more space, which means that there can be more apartments. And so like on the 4th energy level, you can have all 4 shells or sub shells. Here is that examples of the subshells. So you can see that the S subshell is going to be spherical. The P subshells are dumbbell shaped. You can kind of see the dumbbells there. D gets a little bit more complex, and then F gets even more complex. Okay, remember, they are 3-dimensional shapes. And then for 3, what it's telling us is, again, which spatial orientation. So it's telling us kind of like the tilt of the orbital, which kind of also tells us what room it's in. Okay, so within the apartment, if you go with the apartment building analogy, the room in which it's in would be the orientation of the orbital. Because with, as you saw on this slide, P orbital has 3, D has 5, and F has 7. So you'd have to tell me, hey, it's in F minus 3, and then we would be able to tell that. And finally, we have the spin quantum number. So this is the only one that talks about the motion, and we only have really 2 motions. We can spin positively, or we can spin negatively. 2 spins. The biggest thing that this tells us, though, is that each orbit or orbital can only hold 2 electrons, but they have to have different spin. So you can't have 2 electrons that are in the same room that are spinning the same way. It doesn't work. Okay. And that is quantum numbers. Okay. So go ahead and fill out the worksheet. Make sure that you're uploading it so I can grade it. And then if you have any questions, just let me know.